Hello everyone and welcome back to my channel. Today we're going to do something fun. A lot of you have been asking me to make a tutorial on engine sounds in Scratch, so that's exactly what this video is about. I will do this in Turbo Warp, but everything you see here can be replicated one-to-one in vanilla Scratch, so you can just follow along. For our example sound, I will use 5 sprites with 1 sound file each. You will have to create a sprite for each sound file you add. So now I've imported all of my engine sounds here. Also, I like to use lists to make the system easier to add onto, so I will type all of my RPM values of my sound into a list. After that, I create another list, which will be modified when we run the project, where we store the current volume of each sound. So the first step for us in terms of code is that we have to loop the engine sounds. In vanilla Scratch, we do this by using a play sound until done block instead of a forever loop, but I like to have a bit higher audio quality, so I'm going to use the sound expanded extension, which adds a block named start looping, so we can loop the sound file seamlessly. So just a forever loop with play sound until done would sound like this. So even though this sound file itself is looping seamlessly, Scratch is only limited to 30 frames per second, so it's not going to sound quite clean because there's always a small delay between the sound file ending and the sound file being started again. So instead I will use the start looping block from the sound expanded extension, which will sound like this. Sounds much better. So let's add this to all the sprites. When we start the project, every sound file should now play. But now let's head into Desmos to take a look at what we actually want to do with the sound files mathematically, because obviously this does not sound like an engine. We need to make them blend smoothly between each other. As you can see, we have to work with sine waves to get the best result, but I can explain to you why this is necessary, and it is not that hard to implement once you understand what it does. Basic concept is that we want to have smooth blending between our 5 sound files, and they should play right around their target RPM value. So we have a sound at 852 RPM, that's going to play right here, then at 2444 RPM, there's one here, and they should smoothly fade to the next one, as you can see like this, where the volume would go down and the other one rises up when you reach a high enough RPM, where it transitions over to the next file smoothly. And these graphs I've plotted here are actually exact representations of what we need to code. So we want the first sound file to remain at its full volume until we reach a high enough RPM to fade to the next sound, like the second one. Then for the last sound, it's the opposite. It should be faded in smoothly and then stay at its full volume when the RPM is maxed out. Between these two ends, we have the 3 other sound files that we blend between each other, like I shown it here. Let's now quickly code this in Turbo Warp. For this, we also need to create an RPM variable. And so first we need to map this RPM value to a different range. So the range, for example, between 852 RPM and 2444 RPM needs to be turned into a range between 0 and 1. Then we will do the same for the other side, turn the range from 2444 to 4035 RPM into a range from 0 to 1. And since we do this for every single sound file individually, I'm going to create a new counter variable that's going to make this much easier for us. And put this into a repeat loop and repeat this for all of our sound files. So it should be repeated 5 times. And now we need to remap these ranges, as I was just saying. So this is how that's done. It's going to subtract the RPM of the previous sound file from the current RPM and divide that by the RPM of the current sound file minus the RPM of the previous sound file. So pretty much like this. So if we have a value of 852 and the previous RPM is 852, then this is going to be 0, like we can see here. But on the other hand, if we turn this to 2444, this should be exactly 1, or rather 100 as we scaled it up here. So because this is the second file we have, let's set our counter variable to 2. With a slider range of 10,000, we can now play around with it a little bit. Let's take a look. This should now return close to 0 because we're very close to the RPM of the first sound file. Yes. Now we go right around in between. Should be around 0.5 or 0.6. 0.52, perfect. And now up to roughly the RPM of the second sound file, this should be slightly above 1. Perfect. Now we write this to a helper variable. And then now we do the same for the other side, so mapping the range from 2444 to 4035 between 0 and 1. Let's just duplicate this, create another helper variable, and this time we're going to modify this a slight bit. Going to remove the -1, because now we're not only going from the previous to the current, but from the current to the next sound file with the second variable here. So now we have both ends. So A is responsible for this first part, and then B is responsible for this. Now it's also important that we clamp the final values of these two variables between 0 and 1, otherwise it's going to sound completely wrong. So I'm going to show you a way now how this is possible in vanilla Scratch without using custom blocks. So now with our value of I, A would be 1.02, but now we clamp it between 0 and 1, and now it's 1, as it's supposed to be. And now here we're slightly below the previous RPM value, so this should be a negative number. Update this value, and now that's 0. So this is our clamping mechanism, and we also do the same for the other variable. Next up are these sine functions. So this is not just a straight line, as you can see, but this is actually some sine functions and a cosine, which is going to be important. So let's do those. One thing to notice is that Desmos uses radians, so we have 0.5 times pi instead of 90 degrees. In Scratch we would use these 90 degrees, so that's one thing to look out for. But now for the sine waves we need 3 different behaviors. So let's add these if-else blocks, because once again we have the first sound where the volume remains at the maximum until we reach its target RPM. After that it will fade down gradually to 0. The last one is going to fade from 0 to 100 in this RPM range, and then after the RPM is maxed out it's going to stay at 100, and for the other ones we're going to need both sides of the sine wave. So for I equals 1 that's going to be our first sound file, then for I equals length of RPMs is going to be our last sound file. And now this is the volumes list that I was talking about. This is going to be modified at runtime, because now we're going to add all the volume values to the list. As I said, for the first sound file is going to have to be the cosine of the right side, which is B. Then for the last sound file we only want the left side, so that's A, and we're also going to use a sine instead. Then for all the files in between we need both sides, so that's going to be A minus B. We create a forever loop, then turn this into a custom block. Run without screen refresh. This is very important because we have a repeat block here. And now let's see. This should be ranging from 0 to 1, and it should be blending smoothly. Yeah, this looks pretty much perfect already. But now obviously Scratch volume doesn't range from 0 to 1, but instead 0 to 100. So let's multiply every single value in here by 100. So just like this, we have the values for all the volumes. So now what's left to do is that we set the volume of our sound, and then we are going to add this to every single sound. And then set which item it is. So this is the first sound, we can keep the 1 here. This is the second sound, so 2, third sound, 3, fourth sound, 4, fifth sound, 5. So now we should hear some nicely blended together engine sounds. Obviously it's still pretty bad because there is one thing that still needs to be implemented, and that's the correct pitching of the engine sound files. So Scratch uses semitones to pitch the sound effects. So a pitch effect of 10 corresponds to 1 semitone, pitch effect of 120, that's 12 semitones and exactly 1 octave. In the real world, when you want your engine to sound 1 octave higher, your RPM needs to be twice as high. So to achieve this effect, we can use a logarithmic function. I've plotted one for us here in Desmos, using the RPM of our first sound file, that being 852 RPM. When we reach 852 on the x-axis, the horizontal one, the function returns 0. So the sound would remain at the original pitch because we don't apply a pitch effect to it. When we double the RPM to 1704, the function is exactly 1. So that means we go up 1 octave. And the opposite happens if we halve the RPM down to 426, right here, where the function returns -1. So we're going down an octave compared to the original pitch. And the function that we have for this looks like this. And we can actually recreate this one-to-one in Scratch. So we take the ln twice divide the first one by second one. And here we also need the RPM that we're currently at. That was the x-axis. And then the RPMs that we have for the sound files. So this is the fifth sound, so it has the fifth RPM value, 7,218. So if the RPM hits 7,218, this sound is going to be at its original pitch. But now because Scratch uses semitones instead of octaves, we still have to multiply this by 120 to get the exact result. And also we need to set the pitch instead of changing it. That's very important. Now we can add this to all of our engine sound files. Then modify what RPM value we're reading from for each sound file. And now let's hit play again. This should now get us an engine sound that works perfectly fine. One thing to note is that in vanilla Scratch, if you try to pitch your sounds up and down too much, you are going to get some issues with the sound not changing the pitch, because vanilla Scratch is going to limit the pitch effect between minus 360 and 360. So in Turbo Warp, you can go into the advanced settings and remove the miscellaneous limits, which also includes the sound effect limit. But in Scratch, you might have to work around it by using some more engine sound files. I think this works fine, but maybe for you it doesn't, depending on what engine sounds you use. So you will always have to look for yourself if it works or not. For now though, we have created an easy to implement but still very high quality engine sound system entirely in Scratch. And that would also be it for today. If you found this video helpful, make sure to leave a like and subscribe to the channel to not miss out on any fresh content I upload. Till the next video, have a good one.